something that mixes it up a bit. So remember, in general, probability, right, times the first prize, probability times the second prize, probability times the third prize. That's the pattern. You keep going until you have no more prizes to be won, then you just subtract how much it costs you to play. That's basically expected value. Okay. So in this case, the probability of winning is 0.55, and you win 15 tickets if you actually win. If you don't win, you don't get anything. You must give the game operator 10 tickets to play, so that's your cost. So expected value here would be 0.55, that's your probability of winning, times 15, it's like 15 bucks, right? There's no other way to win, so we just subtract the 10 tickets you would lose, okay? So that gives you, if you multiply this, you get 8.25 minus 10. I'll tell you this, if I see this filled in properly, you already get a mark. Just the numbers where they belong, substitution. And then you're going to get another mark for correctly answering this. So this would be negative $1.75. Okay. 1 mark for that. So that's where you get the 2. If you forget the negative, I'll be nice today, just half off if you have 1.75. But in general, it's going to be minus 1. If you play 20 times, how many tickets do you expect to win or lose? So we know we're going to lose because it's negative, right? Negative means losing. So we'll just go 20 times 1.75, and that gives you 35 tickets. Dollars. I've never seen one with tickets, but if they do, then that'll be your unit. You get a mark for that. And obviously, if you get this one wrong, if you get like $10 or $12, you'd go 20 times 12 to get this. You'd still get the answer. You'd still get the mark for the answer. Next. There's a wheel, and you pay $10 to play. So that's your cost. If you land on a star, you get a gift card for $50. If it lands on anything else, you don't get anything. The wheel has 10 stars, 20 X's, and 40 O's. So in total, 10 and 20, that's 30, and 40, that's 70 total. That is important in this case. You need to figure that out. So the expected value, the odds of it landing on a star, so that's just odds, right? So you want this. So basically star and not star. So we have got 10 here, and this should be 60. Right? So 70 in total, 10 are stars, 60 are everything else. Okay, 1 to 6 if you reduce it, but it doesn't matter. No marks taken off. What's the probability of it landing on a star? When it's probability, we want the total down here, and it's 10 out of 70 or 1 over 7. Okay, either one is fine. And think about it, if you used your odds to go to probability, you would add these two to get the 70, and you grab the 10, it works. Okay, you don't have to in this case. The expected value, here it is. Expected value, there's just one prize to be won. So the probability is 10 over 70 to land on a star, and you win $50. No other ways of winning, so we go minus $10 that we paid to play. Okay, so there we go. You get a mark for that substitution done correctly. If you divide this and then multiply it by 50, you get 714 minus 10. If you subtract that, you get negative 2.86. Another mark for getting that correct. Should you play? No. Why? Because it's negative. Okay? Not because it's a small number. If this had been 1 cent, like let's say positive 0.01, you still say you play, okay? Because it's positive, you're still gaining in the long run. So we have what? 4 and 3, that's 7. 7 total. Name and last name on there.